This is starting this video, we are looking at the Newton-Raphson root finding method. So the Newton-Raphson method is another way to estimate a root of an equation. And it's gained by this formula here. And in other words, this is saying that xn plus 1 is saying that the term after the one that we have is equal to xn, and this is a number which it gives you, and then minus f of x, and then that's over the differential of f of x. So this will make more sense when we put it into a question. So this question says that using the Newton-Raphson method, give an approximation to the root of e to the x plus 3x minus 4 is equal to 0, where x1 is equal to 1. So to start this off, what we're going to do is we're going to find out, well, we don't need to find out, we just need to say what f of x is. So f of x is equal to e to the x plus 3x minus 4. We also need to work out now what f dash of x is. So f dash of x is this differentiated, and that is equal to e to the x, because e to the x differentiates to give e to the x, plus 3. So therefore, now we have both of those, and we know that x1 is equal to 1, we can put this into our calculator. And we're going to say that answer is equal to 1. For the first one, that's what we have to put. So then this is what we're putting into our calculator. We say that answer, which is 1, minus, and then we have the f of x, so this is this. We're going to get e, that's the answer, plus 3 answer, minus 4 divided by e to the answer plus 3. So we put it into a calculator, and what we get is 0.6995. Now that is then one, that's the first one. Then all we have to do now is press equals again, and then for, if that was x2, x3 is going to be 0.6773. So therefore, when we keep on doing that, we'll find that that is going to be the same. So therefore, our answer is equal to 0.677. That is an approximation to the root. And it's useful to use this trick on the calculator to make it much easier by using this answer. So the next question has slightly more of a problem-solving element to it. And it says that the curve C has equation y equals fx, where f of x is equal to x to the 4 plus 4x squared minus 6x. So C has exactly 2 real roots and exactly 1 stationary point. So firstly we have to write down one of the roots of C. So this root, which we're going to be writing down, is going to be the simple one, as we can take an x out of this. So if we take an x out of this, we get x, and we get x cubed plus 4x minus 6. Now therefore, one of the roots, x, is going to be equal to 0. So if everything in it has an x in it, it means that one of the roots can be 0 if that is equal to 0. So then in B, this is where we start using the Newton-Raphson method, and we're going to use it twice for different functions. And the first one asks us the other root of this curve. So there's two ways we could do this. We could say that f of x is going to be equal to x to the 4 plus 4x squared minus 6x, but we're going to actually say that f of x is going to be equal to this x cubed plus 4x equals minus 6, because essentially that's the thing that we're finding the other root from. But either way, it will give you the same answer. So, and then f dash of x, so we've got to differentiate this. Differentiating this gives us 3x squared plus 4. So now we've got that, we know that x1 is equal to 1. So therefore we can say answer is equal to 1. So type in 1 and press equals. That is now your answer. So then in order to do this, we have answer minus, then we've got on top, we've got answer cubed plus 4 times answer, and then minus 6. This is divided by 3, then answer squared, and then plus 4. So therefore what we get is x2 is going to be equal to 1.143 and x3 is equal to 1.135. Now what we can round this to is we can say therefore the other root is going to be equal just to 1.1. We can round it to 1 decimal place. So then in the part II, so this is I here, and in II, in part 2, it says the coordinates of a stationary point P on C. So in this one, what we are looking at is we are looking at a stationary point. The derivative is going to be equal to 0. So therefore, we have this. This is our f of x. F dash of x is going to be 4x cubed plus 8x minus 6. Now that, therefore, we are going to use as our f of x. So we're going to say that f of x is equal to 4x cubed plus 8x minus 6. That means that f dash of x is equal to 12x squared plus 8. So therefore, again, we're going to start off with x1 is equal to 1. So we're saying that 1 is equal to the answer to start off. And we're going to put this in. We're going to say answer minus, and then we've got 4 answer squared plus 8 answer minus 6, and then divided by, and then 12 answer squared plus 8. That means that what we're going to get is x2 is equal to 0.7 exactly, and then x3 is going to be equal to 0.63. That there is our value of x. But we're going to store this in our calculator, and now we're going to put it back into our value of y, as y is equal to f of x. So therefore we can say that y is equal to 0.63 to the 4 plus 4 times by 0.63 squared minus 6 times by 0.63. And that is equal to minus 2.035. So rounding it up, we know that our coordinates here are going to be 0.6 minus 2. That's the coordinates of a stationary point P on C. So our final question today says that f of x is equal to sine 2x plus ln of x. So A is saying that show that y equals f of x has a stationary point in the interval 1 to 1.1. Now this will be using the change of sign method, which we looked at a couple of videos ago. So A, now in a stationary point, as we looked at in the last question, that's going to be f dash of x. So we will need to work out f dash of x in this particular question. Now f dash of x is going to be equal to 2 cos 2x. Now if you don't know about all this differentiation, go and watch differentiation videos I made. And that's going to be plus, now it's going to be 1 over x, which we're going to write as x to the minus 1. So therefore, let x equal 1. And what we get when we let x equal 1 is that's going to be equal to 2 cos 2, and then it's going to be plus 1 over 1, which is 1. That is going to be equal to 0.1677. Then letting x equal 1.1, now that's going to be equal to 2 cos 2.2 plus, and then be 1 over 1.1, and that is equal to minus 0.2679. So therefore what we can say is there is a change of sign, so we have shown that there is a stationary point in the interval of 1 and 1.1. Then in B, we're now using the Newton-Raphson procedure, and we're starting with x naught is equal to 1.05. So first of all, we have this already, but this is now going to be f of x. F of x is going to be equal to the 2 cos 2x plus x minus 1, and that's because this is the x coordinate of a stationary point as it here, so we're using that f dash of x. Then f dash of x, this, well, that's going to be equal to minus 4 sine 2x, and then minus x to the minus 2. So therefore now we have that. We're going to let x equal the answer. So let answer equal, and then it's going to be 1.05 because that's what it says that x naught is. So therefore we'll put this into our calculator as answer. So answer minus, and then on the top we have this. So we have 2 cos, and then 2 answer, and then it's going to be plus answer, so minus 1. It's important to put it as minus 1 instead of doing 1 over, otherwise the calculator sometimes will not work and it will come up with a math error. And then below we'll have minus 4 sine, and then 2 answer, and then minus answer to the minus 2. So we put that in, and for x1, so our first one, because it starts at x naught, we shall get 1.036854815. And then for x2, we will get 1.036966397. And it says 2 procedures, so that means that there is our final answer. So thank you for watching this video, and see you soon. Bye.